guys, welcome to Network Nuts. I am Aryan, your instructor for this Ansible training. This training is based on RHEL 9. So we are going to study Ansible on RHEL 9. The code for this course is RH294, also known as RHCE, Red Hat Certified Engineer. This is going to be a long training. There is a lot of content that we're going to cover in this. And today is our first day of this training. I really appreciate all of you joining here with us today. And I hope that you learn Ansible and are able to implement it in the best way possible in your organization. Since we are already done with introductions, let's start. So in this particular training, we are focusing on RHCE on RHEL 9. But before this course was introduced on RHEL 9, this course was also available with us on RHEL 8. But before that, this course did not exist. Red Hat has introduced the technology of Ansible on RHEL 8 and RHEL 9 in the RHCE content. Before that, it used to be available as part of a different course known as DO407, Automation with Ansible. But now the same course has become a part of core Red Hat Certified Engineer skills because we see a rise in the demand for Ansible automation when we talk about DevOps jobs or Linux jobs in general. This particular course is brought to you by AR Network Nuts Private Limited, which is the organization that you are studying with. On today's topic, we will be introducing Ansible. So we are going to cover some theory today. Now, again, not everything is theory. We do have a lot of practical content that we cover. But since it's the first day of this training, we are going to cover some theoretical part to build your base, to build your foundation for this course. Today's topics are going to be understanding what is automation, understanding what is Ansible, what are the benefits of Ansible, what is the need to automate. Ansible works on a mathematical principle. This principle is known as idempotency. So we will talk about what that means. We'll talk about how Ansible works, what are the different terms that we use in Ansible. Installing Ansible, we will not be covering today. We'll be covering it in the next particular day. So let's first talk about what is automation. Now, most of you here might already be working in some organization. And everybody has a different meaning for DevOps and a different meaning for automation. So I'll tell you what I understand by automation. Automation for me is doing a particular job in such a manner that we never have to do it again. So say you're a Linux admin, you need to do a particular job at a particular time every day. You can write a cron job for that. And that simple cron job is also an example of automation because instead of having to run the command yourself, you are able to run the command by scheduling it using cron. So that's automation. Automation comes in a variety of forms, right? Not every single piece of automation needs to be something very advanced. It can be as simple as a cron job, or it could be as advanced as a CI/CD pipeline. So there are a lot of different ways you could describe automation. Your course provider, Red Hat, describes automation as a situation where the person meets a problem that they never want to solve again. So automation happens when a person meets a problem that they never want to solve again. So there is a particular situation that you are working on and you want to automate it or create such an environment that that issue, that situation is automatically solved and manual intervention is not at all required. In our particular case, what kind of automation are we referring to? So in terms of Linux, in terms of Ansible, in terms of this training, automation here refers to the idea that we have a lot of Linux servers, perhaps Red Hat or CentOS or Ubuntu or something else. And you want to install packages on those servers. You want to copy files, create directories, manage users, manage logical volumes, manage partitions, etc., on all those servers. You could manually connect to those servers and do that. That's possible, but it would take a lot of time. And these are the kind of problems that we are talking about. So how do you manage Linux servers at scale? That is what we are trying to achieve via Ansible, via automation. So why do we use Ansible for this? We have a lot of options available when it comes to doing automation. You could perhaps work with Ansible or maybe Puppet or some other technology, or even something as rudimentary as bash shell scripting. However, we prefer using Ansible because there are certain benefits that Ansible provides us. The first one being that Ansible is simple. When we say that Ansible is simple, we mean to say that there is no coding knowledge required to learn Ansible, right? Even though Ansible is based on Python, whatever you do in Ansible is actually happening via Python in the backend. We don't actually need Python. There is no requirement of the user to learn Python in order to understand Ansible. Of course, if you know Python, you are at a +1, you are at an advantage, but there is no requirement to do so. Because it requires no programming language, no prerequisite language is required to learn in order to use Ansible, productivity comes quicker. Our users, our employees, whoever Ansible is meant for, whoever is going to be using Ansible, those people are going to be able to use it without any knowledge of a programming language, which is a barrier that a lot of people often face, right? That they don't want to learn a programming language. Ansible is powerful. So initially meant for Linux automation, Ansible can now automate a variety of stuff. You could automate network devices, Cisco, VYOS, etc. You could automate Microsoft Windows. So Windows server management, you want to install Windows packages, create users, manage services, create files, create directories, anything Windows admin related you want to do, you can do on a larger scale using Ansible. Then Ansible can also be used for cloud environments. So you want to automate AWS or Azure or Google Cloud, you can do that. VMware automation, OpenStack automation for virtualization is also available. So Ansible can automate a variety of stuff. It is not only limited to the automation of Linux. Obviously, that's what we are going to focus on. We are here to learn how to use Ansible for Linux automation, but technically speaking, you could automate other stuff with it as well. So irrespective of where the organization is in the SDLC, in the software development lifecycle, whether you are a part of development or production or testing or whatever stage you are a part of, you can use Ansible in some form or the other. And the third point, which is Ansible is agentless. This is the best selling point of Ansible. And this is something that we really focus on, the agentless architecture of Ansible. So initial automation technologies such as Puppet, for example, not sure if you've heard of it. It used to be very famous at a time in the past. Puppet used an agent-based architecture where you had to install a software on every single server in order to be able to connect to it and manage it via Puppet. We used to call it the Puppet client. So there would be two softwares, the Puppet client and the Puppet server. Puppet server you would end up installing on your workstation, and Puppet client you would end up installing on all the remote servers. And only when the server and client packages have been installed will you be able to end up using it properly. However, Ansible follows no such idea. Ansible requires two technologies to work, SSH and Python. In any Linux-based operating system, whether you end up working with RHEL or CentOS or Rocky or SUSE or Ubuntu or whatever, you will always find SSH and Python pre-installed. So you don't need to install SSH, you don't need to install Python. Ansible uses Python to perform the jobs and SSH to create a secure connection. When connecting to a Linux-based server, we end up using SSH. And when connecting to a Windows-based server, we end up using WinRM. So we have methods available to connect to Windows as well. Because Ansible uses SSH to create the connection, no other packages installation is required. The user has no prerequisite software to meet, no repositories to enable. Nothing is required on the remote servers. You can start using Ansible right away. All you need is an SSH connection. You can use a key-based authentication, or you can also use a password-based authentication, depending upon what kind of environment you are dealing with. This is a list of technologies that Ansible can automate for you. Your training will be focused on RHEL and Linux, but technically speaking, if I know Ansible, I can work with a variety of stuff that we have already talked about. But why do we automate in the very first place is very important to understand. If you go back 7 years in the past, nobody was talking about DevOps or automation, but something has changed over the past couple of years that we have introduced the idea of DevOps, introduced the idea of automation in the industry, in the IT industry. Why? Uh, there are a lot of answers for this. The major answer that I very much believe in is that internet, internet all around the world has gotten really, really cheap, which means that people all around the world are getting access to different services, different applications, different websites. More and more people today use Instagram or Facebook or Threads, or you use YouTube or any other way of consuming an internet-based service, whatever you prefer. And because more and more people are consuming these services, the demand is increasing, and to cater to the demand, the supply also needs to be increased. Applications, organizations which could in the past perhaps run with 100 servers are today requiring 1,000 servers. The number of servers required have increased. Thus, also have the number of network adapters and network devices and all other things that come with it. Now, you need people to automate these processes, to manage these processes. I could hire a lot of people to manually manage my lot of servers, but that's going to be a waste of my money and my time. I want people who should be able to very quickly configure my servers and manage my servers. And that is where we bring in Ansible. So people who know Ansible can take care of this stuff for you. So we automate because we don't want to spend a lot of time doing manual jobs such as package installation or user management or service management or file or directory management. We don't want to do that. Manually, it takes a lot of time. And even if you're able to do it manually, you are ultimately a human and you could end up making a mistake at some point of time. Ansible or any technology for that matter, if created properly, if managed properly, will not make any mistakes. So the same automation process that's running today will also end up running tomorrow. You will not face any problems. So your environment will remain stable. And ultimately, it's all about money. An organization would want to hire the minimum number of people possible to take care of the job, to save money and to increase their profits. Similarly, if you want to have that job promotion that you want or deserve, you want to switch to a better organization, you will want to learn the best skills possible. And we also automate because we, as people who work in this industry, we need to keep on growing to ensure that we are not on the bench or to ensure that we are always in demand. And that is why we automate. So what is Ansible? You are already aware of this now, so we can skip this step, not waste your time. Idempotency. Ansible works on the principle of idempotency. Idempotency is a very important principle to understand. And the idea here is very simple. Forget what is there on the screen. Listen to me. You have with you a smartphone. On that smartphone is an app for your bank. Whatever bank you end up using, you have an app for that. Let's say that I have an app for the JP Morgan Chase Bank. And using this app, I can make transactions. I can check my account balance, whatever amount of money I have, I can check that. So let's say that on my app, there's a refresh button available, that when I click on that button, I can refresh the balance. I can ensure that the latest balance appears. Now, if I click on the refresh button, will my balance change every single time? So if I open the app, click on the refresh button, is my balance going to change every single time I click on the button? It's not. I could keep on clicking on the button, but my balance will not change because my latest bank balance has already been shown on the screen. So you can keep on hitting refresh, nothing is going to happen. It won't increase, unfortunately, but it will also not decrease. A change in the account balance will only happen when a transaction takes place, when there is a debit or a credit. If there is no debit, if there is no credit, then there is going to be no change in the balance. Everything is going to end up remaining the same. Ansible works on the same idea. If I have written an Ansible script, what we call a playbook, and execute it today, to create a user or to install a package. And tomorrow, if somebody else executes the same script or the same playbook, Ansible will not create the user twice. Ansible will not install the package twice. It will simply not do anything because the desired result has already been achieved. So you already have the user created, you already have the package installed. So nothing is going to happen. Ansible will not give you an error. It will simply not do anything. Just like you're checking the account balance example, you can keep on hitting the refresh button, but the JP Morgan Chase app is not going to do anything because the latest bank balance has already been achieved. So you keep on clicking refresh, your balance is not going to increase, it's not going to decrease. And Ansible works on the same idea that we can end up running the script twice, thrice, 10 times, hundreds of times. But if that particular script or playbook has already achieved its output, nothing is going to happen. There will be no error. It will simply not do anything. Now that we understand how Ansible works or how Ansible behaves, let's understand how it properly works. So let's go a little technical and try to understand how things happen in the background. So we have an older way of using Ansible and we have a new way of using Ansible. We are talking about a newer method now, which we call Ansible Navigator. Ansible Navigator is also Ansible, but uses the technology of containerization. So earlier versions of Ansible, such as Ansible Community or Ansible Core, did not have the idea of container integration, which Ansible Navigator has. Navigator has been around for a while now, but has recently become very popular. And we see organizations now shifting to Ansible Navigator and using Ansible Navigator for their Ansible jobs or whatever Ansible related requirements they have. First thing is SSH. Ansible requires an SSH authentication. You have a password-based authentication. You also have a key-based authentication. Now, Ansible by default uses a key-based authentication. If you want, you can shift to a password-based authentication as well. That option is available, but we by default use a key-based authentication. For SSH to happen, port number 22 needs to be allowed in the firewall. So we are assuming that you have a server which we call control node. Control node is a server on which we install Ansible. And this is a server that we create and save the Ansible scripts or the Ansible playbooks on. And then you have a group of servers that you want to manage using Ansible. The server that we want to manage using Ansible, we call it the managed host. That is the server that we manage via Ansible. On both the servers, port number 22 should be allowed in the firewall. As you can see in the diagram as well, port number 22 needs to be there in the firewall because Ansible uses port 22 for SSH. Now you need a key-based authentication. So it is my assumption that you are already aware of how SSH works. You know what is a key-based authentication. You know what's a password-based authentication as well. And Ansible uses a key-based authentication. You could work with any user of your choice. We see people often using the root user directly. That's not recommended. We prefer that you use a normal user for security reasons. Now, Ansible Navigator is the Ansible technology here at play. And this technology creates a container which is using your container runtime engine. So in the case of Red Hat, it's using Podman. And using this Podman container, it runs your script or your playbook on the remote server. But how is this Podman container created? This Podman container is created from a container image. Ansible Navigator will automatically download the container image when you run it for the very first time. A publicly available image is available on QA. That's one of the container registries sponsored by Red Hat. And Ansible Navigator will automatically download a container image from the QA registry. If you have other container images available, Ansible Navigator can use them as well, assuming that they are compatible with Ansible Navigator. So if you have one on your private container registry, you can use that. Or if you want to use one from the Red Hat's official registry, you can use that. Or if you want to use a free one, then the QA Ansible container registry is available. So Ansible Navigator is going to download this container image. Size will be around 1.1 GB, 1.2 GB on the control node Ansible Navigator virtual machine. Using this image, it will spin up an Ansible container using your container runtime. In our case, that's going to be Podman. And this container is going to be running your playbook or your script on the other server. That's the other group of servers. This particular playbook is going to be executed by the respective container, and this container will run the playbook. Now, either the job will be a success or the job is going to be a failure. There are two possibilities available. In both the cases, the container is going to be automatically deleted the moment the job ends. So we don't care whether the job is a success or the job is a failure. That container is created for a single time use only. The moment the job ends, the container is deleted, automatically terminated. The image that is downloaded from the container registry is obviously there. That is not removed. But the container that was pinned up is automatically destroyed the moment the job is done. When you rerun the same playbook or you rerun a new playbook, the new container will automatically be created. Why do we have the idea of containers? What advantage does this give us? Now, the problem that we were facing with Ansible, the earlier versions of Ansible, was that in an organization, you have the SDLC, the software development lifecycle. And it is possible that systems in different life cycles are using different versions of Ansible. So I'm using Ansible 2.9, you're using 2.8, somebody's using 2.2. Everybody's using a different version of Ansible, which will create a problem because changes or behavior will be inconsistent across environments. But when you use a container is immutable in nature. It cannot be changed. So the container works the same way as it is working here, as it would work for you, as it would work for anywhere else in the world, which ensures that everybody gets the same experience. So earlier what was happening again was that the scripts that I was writing for my environment were perhaps working for me because I was writing them according to my Ansible version and configuration, but they were not working for you because you were using a different version of Ansible. But when you employ a container-based architecture, the container remains the same for everybody because the container image remains the same for everyone. So the same container image that you are using, I am using. So our Ansible environments remain consistent and the job is done without any problems. So everything remains the same, but instead of directly using Ansible, we use Ansible via a container, and that container engine is decided according to your respective operating system. Now, the next thing that we will require is the installation of all of this stuff. So we will require installing Ansible Navigator. We will require installing the respective packages that will be required. We will also have to create certain files that are not mentioned here. So I'll just mention them for you quickly. So there is another file that you need, which is known as the ansible.cfg file. CFG is a common term, right? Any kind of file that decides the behavior of a service or a software is its configuration file. So how will Ansible behave is decided by its configuration file. So this file will be required. And we will be creating this file. Another file that you will require is the inventory file. Which particular servers am I going to connect to via Ansible? That's decided by the Ansible's inventory. And the third file that you will require, aside from the playbook, is going to be the Ansible Navigator.yml file. And this file will decide the behavior of Ansible Navigator. Ansible Navigator is a software that you are using to have this container-based Ansible architecture. And these three files will have to be created by you. So as we go on with the training, we will be learning how to create the Ansible.cfg, the inventory, the Navigator YAML, and the playbook. That will help us in performing the perfect Ansible execution. That is it for today. And I'll see you guys in the next session.